Today we started in the small intestine, when we compared the number of food molecules from the stomach and the beginning of the small intestine. We saw that the number of amino acids increased and the number of protein decreased. That makes sense because we know that a chemical reaction was breaking the protein molecules into amino acid molecules. We saw the same thing happening with the fatty acids and the fats, because the fats were being broken down into fatty acid molecules. And we saw the same thing with the glucose and complex carbohydrates. Complex carbohydrate molecules were breaking down into glucose molecules. Next, we followed our food molecules to the middle of the small intestine. We saw that the number of amino acids and proteins decreased to 0, which made us wonder, what happened to the small amino acid molecules? We saw the fatty acids increase and the fat decrease, which makes sense because we knew a chemical reaction was occurring. And we saw the same thing with glucose and other complex carbohydrates. Finally, we ended our journey today at the large intestine. We saw that the number of fatty acids decreased to 0, which again made us wonder what was happening to these small broken down food molecules. The same thing happened with glucose. The number of glucose molecules went down to 0, which made us wonder what is happening to these broken up glucose molecules. Our understanding of chemical reactions helped us understand what happened to these larger molecules. The complex carbohydrates broke down into glucose molecules. The fats broke down into fatty acid molecules. And the protein molecules broke down into amino acids. But what happened to these broken down molecules? The answer is a structure in our small intestine called the villi. Villi are sometimes described as finger-like structures because they're shaped like fingers. The function or job of villi is to absorb these broken down molecules through membranes into the bloodstream. Once these molecules are in your bloodstream, they go throughout your body to other cells. We'll learn more about that later. Here's a picture of your small intestine. Here you can see the villi, or the finger-like structures, and that the membranes allow the food molecules to go into your bloodstream. Let's look at an online simulation that will help us better understand the function or job of villi. Here we can see the height of the villi. Right now it's 0. Right now it's 5. And right now it's 10. The number of small food particles that start out in the small intestine is 110, and we can see them represented by these dots. The longer ones are complex carbohydrates, proteins, and fats, and the smaller ones are glucose, fatty acids, and amino acids. This shows me that we're going to see how many of these food particles are absorbed into the bloodstream in 14 hours. Let's start with our villi at 0. When the villi height is 0, we can see that very few of the molecules are making it into the bloodstream. We can see that 6 hours have passed so far in our simulation, 8 hours now, but still very few of these food molecules are making it into the bloodstream. We're now done. It's been 14 hours, and we can see that 33.3% of the food particles were absorbed into the blood. Let's write that here, 33.3%. Now the villi height is 5. We started with the same number of small food particles in the small intestine, and our simulation is still going for 14 hours. But you can see that many more of the food particles are getting absorbed into the bloodstream this time. It's been 14 hours. This time, 44.2% of the particles were absorbed into the blood. 44.2% when the villi height was 5. The villi height is now 10. They're much taller. We can see already that the number of food particles being absorbed is much higher. It's happening much faster. Most of the food particles that are being absorbed are the broken down food particles. It's been 12 hours, 13 hours, 14 hours. 59.2% of the particles were absorbed into the blood. Our evidence supports the claim that the taller the villi height, the higher the percentage of food particles absorbed.